In this video, we're going to learn about how we name ionic and covalent compounds. So let's start with ionic compounds. So as you may know, ionic compounds consist of cations, which are positively charged, sodium, for instance, and anions, which are negatively charged, and this would be sodium chloride. Now, the numbers of each are determined by the charges on the particular ions involved. Ionic compounds have a net charge of 0. So in our example, sodium chloride has a net charge of 0. To name an ionic compound, we simply write the name of the cation followed by the name of the anion. Cation names are quite straightforward. Monatomic cations are named for the element from which they are derived. So for instance, sodium 1 plus, we would call this a sodium ion. Sodium ion. Now, when metals can form ions with different charges, the name of the ion must provide this information. The more modern and systematic method involves placing a Roman numeral in parentheses after the name of the metal to indicate its charge. So for instance, iron can be 2 plus, and it can also be 3 plus. In this case, we would write the names of these ions as iron 2 and iron 3. The most common polyatomic inorganic cation that you should know is the ammonium ion, which is NH4 1 plus, and this is called ammonium. Now, let's move on to naming anions. So here I've provided a table of all the anions that you would come across in your curriculum, and the easiest solution to understanding these is unfortunately memorization. But nonetheless, I'll go over the basic logic for how these are named. So monatomic anions are named by removing the end of the name of the element and adding the suffix IDE. So in our previous example, chlorine 1 minus would be called chloride, IDE. A number of polyatomic inorganic anions, however, exist. The names of the ones that should be known are listed in this table, as I indicated earlier. And several generalizations are possible. Now, oxyanions in other words, anions containing oxygen in addition to another element generally have names ending in ATE or ITE. So for instance, you'll notice we have nitrate and nitrite. The ATE ending is used for the anion with the larger number of oxygen atoms, so larger oxygen, and the ITE ending is used for anions with fewer numbers of oxygen atoms. For elements that form more than 2 oxyanions, the prefix is per, which goes for the largest number of oxygen atoms. So per largest number of oxygen. And in contrast, hypo is the prefix for the least number of oxygen atoms. Now, oxyanions that contain hydrogen have the word hydrogen in their names. They may also be named non-systematically using the prefix bi. Now, finally, let's move on to naming covalent compounds. If a pair of elements only forms one compound, the compound is named using the name of the element that appears first in the molecular formula, followed by the name of the second element with the suffix IDE. For instance, NF3 exists singularly, so we would call this nitrogen fluoride. As you can see, this is quite similar to the naming used for ionic compounds. However, if the pair of elements can form more than one compound, prefixes are used to denote the number of atoms of each type in the molecular formula of the compound. So, di is used for 2, tri to indicate 3, tetra to indicate 4, penta to indicate 5, and hexa to indicate 6. Mono, for 1, is sometimes used for the second element named, but rarely for the first element. Mono 1. And remember, this is for the second element. For instance, we would have carbon dioxide, CO2, and we would name this compound CO carbon monoxide. If the use of a prefix results in 2 vowels in a row, the vowel from the prefix is usually dropped to avoid awkward pronunciations. So for instance, for N2O4, we would call this dinitrogen tetroxide instead of dinitrogen tetraoxide. If the compound is a solid without well-defined molecules, it is the empirical formula that is used for naming. Now, some general names that do not follow these conventions also exist. For instance, H2O is called water, NH3 is called ammonia, and lastly, H2O2 is called hydrogen peroxide.